Hello folks, welcome to my first attempt at a screencast. When we're dealing with charges in electric fields, there are three quantities that we care about. First, the electric field. This is a vector and it has a value in every point in space. We made diagrams to consider how this is created a couple of weeks ago. The second thing we have is the electric force. When a charged object is in an electric field, it experiences a force. This is on a particular charged object. It's a vector and it has a direction. And third, we have the electric charge. This is a number or a scalar and has no direction. It can be positive or negative. It's a property of a particular object in the problem. We connect these with the formula F equals QE. When a charge is in a field, it experiences a force. In these problems, we have two vectors, the force and the electric field, and we have one scalar, the charge. When the charge is positive, that tells us that the directions of the force and the electric field are the same. When the charge is negative, that tells us that the force and the electric field are in opposite directions. By opposite directions, I mean if one of them is up, then the other one is down. If one's left, the other's right. One's east, the other's west, etc. All right, let's look at a particular problem. First, we'll read the problem. A minus 2 times 10 to the minus 5 Coulomb charge is placed in a 4 times 10 to the 4 Newton per Coulomb field, which is pointing up. Determine the magnitude and direction of the electric force on the charge. First, you need to identify the information that you're given. In this problem, we are given, we have a minus 2 times 10 to the minus 5 Coulomb charge. That would be Q. So we would write that in our key, minus 2 times 10 to the minus 5 coulombs. It is placed in a 4 times 10 to the 4th newtons per coulomb field. So this is talking about the electric field, pointing up. So we'll say 4 times 10 to the 4th newtons per coulomb. Now charges will always have the units of coulombs. Forces will have units of newtons, and electric fields will have units of newtons per coulomb. This makes it very easy to identify which of them is which. All right. So now we move on to trying to make sense of the directions and the charges. Here we have a negative charge, so when the charge is less than 0, we see that the electric field and the force are in opposite directions. So we had that the electric field was up, and we had to have that the force has to be down. All right, so now we're going to plug into the formula, F equals QE. We have minus 2 times 10 to the minus 5 coulombs times 4 times 10 to the 4th newtons per coulomb. We multiply them together, we get minus 0.8 newtons. Now, if you remember when we talked about vectors, we would often talk about the sign of the vector indicating the direction. Here we had our electric field was up, and we treated it as being positive. When we solve this problem, we get a negative sign, and that tells us that the force is down, which is what we expected from this point over here, that the charge was negative. Problem number 2. A charged object is placed in a right-facing electric field with magnitude 4 times 10 to the 5th newtons per coulomb. It experiences a leftward force of 2 newtons. What is the charge on the object? All right, so our electric field is 4 times 10 to the 5th newtons per coulomb to the right. And our force is 2 newtons, and it's to the left. For consistency, it's a good idea to treat the vectors and their signs the way that we did when we were talking about vectors. To the right is positive, and to the left we call negative. This helps to keep things organized You can do this in your head, but it's not quite as simple. All right. Now we've got to make sense of the directions and the charges. Here, do we have the electric field in the same or in the opposite direction from the force? Clearly one is to the right and one is to the left, so that is the opposite direction. So we know that Q is going to have to be less than 0. Let's keep that in mind as we go. Now we plug that into the formula, and so we have minus 2 newtons equals Q times plus 4 times 10 to the 4th newtons per coulomb. I plug the force into the F and the electric field into the E. And I divide both sides by 4 times 10 to the 4th newtons per coulomb. And we get a charge of minus 5 times 10 to the minus 5 coulombs.